Hello, everybody. What we're going to be doing today is just going over what you need to work on programming homework number 5 here. So, this is mostly for people who weren't in class when we started this and are submitting this online. Main thing to keep in mind is that you need to submit this, of course, before the end of class. It's not a long assignment. I think many of the people managed to complete it in one lab session, so about an hour. Uh, yeah, we'll just go through the beginning of this so you can get what the point is. Programming homework 5 is about finite state machines, right? What you have to do basically is a two problem lab report here, where the first problem is you're going to be implementing the state machine for this elevator that I describe here. And then for the second problem, you're going to implement any state machine you want. And, we'll talk about that more in a little bit. But basically, if you have like an interesting idea for a state machine, you can use it. If you don't have a interesting idea for a state machine, then you can just grab the book, open it to section 13.2, and find the state diagram or the state table for something with maybe 3 or 4 states, and you can implement that in MATLAB. It's very simple to do, or it should be pretty simple to do after you've completed the first problem already, right? Once you've done one state machine, you've really done everything you need to understand state machines. I will talk you through this first one here. So the first problem here says that what we're looking at is an elevator. So there are 4 floors that the elevator can visit. So we got a basement, a floor 1, a floor 2, and a floor 3. The elevator only has 2 buttons. So there's no like door close, door open buttons, nothing like that. Literally, you're just on an elevator and the elevator can go up and down. That's what we're saying here. Okay. Now, if the user presses up, the elevator goes up to the next floor if it can, right? If you're already on floor 3, which is the highest floor, you can't go up. If the user presses the down button, the elevator goes down to the next floor, unless it's already in the basement. If you're in the basement, you can't go down. And then also the starting state is floor 1, which we're going to call state 1. And I don't know why. That's just so we're not starting at the basement, is all I'm saying there. We're starting at floor 1. Now, we can model this elevator as a finite state machine. What you do is your floors are your states. So the basement is state 0, the floor 1 is state 1, floor 2 is state 2, and floor 3 is state 3. Your inputs are the buttons. The only inputs are up and down. There's no input for like do nothing or open door or anything like that, right? So every time through the state machine, essentially the input is either up or down, and there's no option for no input. You could add a no input option to this input list, but we're not. We're just going to do up and down. Okay. Now for output, normally the output of the elevator would be actually making the decision like to go up, right? So you'd be turning on the motors or whatever it is to actually go to the floor. But in this state machine that we're doing in MATLAB, we're not controlling anything. So all we're going to do for output is, if you're going to go up to floor 2, you say going up to floor 2. If you're going to go down to floor 2, you say going down to floor 2. If you can't go anywhere because you were on a floor and asked, like if you were on the top floor and asked to go up, then you should say that you can't go up. Something like that. Okay. And what we want to do is just code this up. And we're going to code this up in a very methodical way that is pretty much the way you could do any state machine. Now, some of the code things that we do are going to be maybe a little bit odd. I'm trying to keep this similar to what you would do in like a lower level programming language, but we can only do that to a certain extent. But if you look up state machines somewhere else, how to code them up, this will look familiar, but not identical to what we're going to do. Okay, so let's go ahead and get started. So when we're getting started, we should create a new script file. So I'm doing this in Octave, so I can go new script. Okay, now right away, I can save this, and I'm just going to save this as elevator .m. There it is. Okay, so the script does nothing right now. So when we're getting started with this, what we need to do is we are going to have to set up some variables before we get started. So a couple of the variables are, we're going to need a variable for the current state, which I'll just call current state. And I'm going to make the current state equal to 1, because remember, we're going to use, for our states, the states are, 0, 1, 2, and 3. And 0 is the basement. And then after that, floor 1, state 1, floor 2, state 2, floor 3, state 3. And we're supposed to be starting in floor 1. So I'm just going to set the current state to 1. Now, actually, the value that I put there is not going to matter, because we're going to immediately override it with the next state once we get into our loop. So there's going to be a variable for the current state, and there's going to be a variable for the next state. Okay. Basically, all state machines work this way. Now, what we're going to do is we're going to have a while loop, and all of our state machine happens inside this while loop. And it's while 1, or like while, true type thing. And so this loop here is an infinite loop. Once this loop starts, you're just going to be stuck in this loop forever. Okay. And the first thing you do in this loop, where the finite state machine is going to be processed repeatedly, is we are going to update the state. So the way you update the state is you just say the current state is going to be equal to the next state. So almost any kind of coded up state machine that you can find is going to look like this. There's always like a line of code that just updates the state, and it's always just current state equals next state. Further down, there's going to be a block of code that updates the next state with where we're going to go next. Okay. This is also why I said it didn't matter what this was, right? Like I can put like anything there. Well, that's not, valid input, but I could put that there and it wouldn't matter, because the first thing that happens is this, and the current state gets overwritten. But I'm just setting them both to 1, and we'll be in state 1 at this point. Okay. Now, normally a state machine should get input from an outside source, but this code here is not a function. It has no way to get input from an outside source. And so because it has no way to get input from an outside source, I'm just going to ask the user for input. Okay, so there's an up button and there's a down button, and I'm just going to make the user type one of those in. Okay, now just to save time, I'm going to copy paste this from the previous time I coded this up. And we'll look at this and we'll put it in. Whoa. So let me do this. Okay, so here's our loop. I'm going to change these to ends, right? If you're using MATLAB, end if is not a valid code, but end is. Okay. Also, this is wrong. That's a variable here. Okay. So what's going on? So first of all, I'm going to have this variable called get input. So what get input does is it tells me whether or not I need to get input from the user. There's probably like a more elegant way to do this, but I don't know off the top of my head this was the first thing I thought of. So this is what I'm going to do. So you see right now, if I set this to 0 and I just save this and I try to run this code, well, first of all, this is an infinite loop. So I'm going to save this and I'm going to come run this. Oops, it was already running somehow. If I run this, bug, I'm missing another underscore. I'm missing underscores everywhere. Fix let me fix this code up a little bit here. Okay. Okay. So basically what's going to happen is if this get input is 1, we're going to ask for input. So let me try to run this again, see if we get an error. We do, because these copy pasting from a PDF just doesn't work, guys. Don't try it. Save it again and try to run it again. Okay, fine. Good. This is what we should have. So you see that I ran this, and also, so I was trying to make it bigger and failed. Let me go back to the command prompt here. Please scroll. Okay, there we go. So you can see that elevator ran and we didn't get back to the regular octave prompt. That's because we're in an infinite loop. So I'm going to hit Control C, which will break the infinite loop and just stop this. Okay, and nothing happened there, right? If I set get input to 1 now, what will happen when I run this? Probably we'll have more errors, but actually we will because of this. Let's try to run this. There we go. So what will happen is it will ask you for input. And what this little loop is supposed to do is if I give a bad entry, then it keeps asking me. So it's just going to keep doing this until I actually answer one of the valid options. So the valid options are up and down and quit. I added quit just in case you want to like quit the program. So like if I type quit, that's how you get back to the command prompt. Okay. And so if you look in here, what I do first of all is this line of code asks the user for input. And so there's a built-in function called input that will display some text on the screen. That's the message I want to display. Type up for up, down for down, quit for quit. And then this S here on the end tells me that the user is going to type a string and I return it as a string. So whatever the user types gets stored in this variable called user input. And then what I have to do is just look at user input to see what the user typed in. So you can't use equals equals with strings, right? Like I can't do this. Like I can't do like hi equals no, right? Like what you would want that to do is if hi is equal to no, right, it should return 1, and if hi is not equal to no, it should return 0, right? But it doesn't. It actually treats this as an array, and this is an array, and you actually get zeros and ones based on whether the first characters were equal and whether the second characters were equal, right? So H is not no, so you get a 0. I is not O, so you get a 0, right? If I do this, then you get 1 0 because the ends are the same, but the I and the O are not, right? So do you see, you can't really compare a string that way. So if you want to compare a string, you have to use this string compare function, right? Now I can do this and it's going to tell me 0. Those are not equal. But if they are equal, then it returns a 1. So that's how we check if a string is equal to another string. So we get the user's input, up, down, or quit. And then if they typed quit, we return. That's what actually stops the script from running. That's why I can run this elevator. And if I type quit, we just go back to the command prompt. So that's what this does. And then if the user does not type quit, right, then they typed up or down. So if they typed up, Or if they typed down, that's valid input. So I want to leave this input loop, right? Remember that when you come here, you type nonsense and it doesn't let you out, right? In order to get past this, you have to type valid input. Now, of course, um, I have more errors at this point, but up was valid input, right? So this right here is trying to catch valid input. The only valid input is up or down. So when you write your own state machine for problem two, whatever the user can type in for input, you just change this if statement here to match what valid input there is, right? Mine's up or down. Yours could be whatever it is, like 0 or 1 or whatever. Now also, this was another underscore that didn't copy paste from the PDF. So what happened now, after I fixed that, is you type nonsense, you can't get out. You type up or down or quit, and you get through it. Now, you're still in an infinite loop, so it still locks up at that point, so I have to hit Control C. But this block of code now works. So this block of code is just my get input thing. So you can copy this format if you need to get input from the user. Okay. Now, this is just because we don't have another way to get input. So this is not really part of the state machine. This is just we need to get the input before we can get going. Okay. Now, once you get past this point, then we can actually get into processing the state machine, right? And so the state machine has 4 states, right? 0, 1, 2, and 3. And also we have 2 inputs, up or down. So what we need to do is in a big if statement, essentially, we need to just cover all of the possible cases for up and down. So what you have to do is, first of all, is see if what current state we're in, right? So if the current state is equal to 0, right? That's the bottom state. Then what? Well, if we're in the current state 0, the user can type up and the user can type down, right? So if the user typed up, which you'll have to use a string compare again. So if the user typed up, what happens? Okay, so if the current state is 0 and the user typed up, shouldn't we go to floor 1, right? Current state 0 is the basement. So if the user types up and you're in the basement, we need to go to floor 1. So we'll display that on the screen, going to floor 1. And I'll even say up, right? Because we were in the basement. So we're going up to floor 1. That's one of the things we should say. That's the output. And the other thing we need to do if we're going up is we actually need to change the state. So the way you change the state is we change the next state. You just say next state equals 1, right? If you're in state 0 and we're going up, you're going to end up in state 1. If you're using MATLAB, remember end, not end if. So there we go. We've taken care of the up input. Now for the down input, you do it exactly the same. Just copy paste that and say if the user typed down, then what should happen? Well, you're in the basement. So if you're in the basement and the user types in down, nothing should happen. So you should say something like that, like can't. You have to hit apostrophe twice if you want to type an apostrophe. So can't go down from basement, right? If they try to go down, and if this is all current state 0, well, if you are in state 0 and you try to go down, you can't. So your next state is going to be 0. Okay, so a block like this takes care of the entire logic for what to do if you're in state 0, right? It's just state 0 and then up or down. And then once you have that, you just reproduce this for every state that you have to do. State 1, for example. So what do you do for state 1? Well, first of all, state 1 should only happen if the current state is 1. And if you're in the current state 1 and the user types up, then we should be going to floor 2. So you say you're going to floor 2, and also the next state should be 2. Now, if you're in state 1 and the user types down, we should go down. So this is the wrong message. We should say going down to basement. And also the next state should be 0, right? So when you're in floor 1, you can either go up to the floor 2 or you can go down to floor 1, floor 0. Okay? And that takes care of state 1. So once you implement state 0, state 1, state 2, state 3, you're done, right? If I stop this right now, you'll see that it won't work. Well, there's one thing I have to do at the bottom as well. So my input loop, this is how I leave my input loop. Hold on, I got if return end, if that, do that, end. Shouldn't that match up with that? Sorry, I'm just comparing my if statements here. Okay, I think those are going to match up now. But anyway, what I was needed to do here is get input 0 tells me that I don't need to get input. So the last thing I do in my while loop, which my while loop, the big while loop, is I should set this back to 1. That will mean I need to ask the user what to do again. So let me save this. I might have an error with end statements. Okay, so nonsense does nothing. Now remember, I'm in floor 1. Actually, I should have displayed a notice that I'm in floor 1, but I didn't. But we're in floor 1. So if I go down, I should go down to the basement. And it says, yes, going down to the basement. If I type up, I should go up to floor 1. And it says going up to floor 1. Right? I can go down again. I'm going down to the basement. If I try to go down from the basement, it tells me I can't go down. I can go up to floor 1. If I try to go up to floor 2, I go up to floor 2, but I can't do anything now because I didn't actually implement the logic for floor 2 yet. So I'm stuck on floor 2 now, right? If I go down or up, doesn't matter. I'm just going to get stuck. Yeah. Okay, so like I'm stuck here, so I have to quit. So you implement these. It's not that hard. I need another, right? Next state, it's going to be 2. I'm going to do these quick because, you're supposed to do these, not me. But I'll just make it work real quick. And if you copy it, you copy it. So current state floor 3, the last floor. You can't go up from floor 3. Can't go up from floor 3. Stay in floor 3, but you can go down, going down to floor 2. Okay, so I think I implemented them all. One thing I want to do is before we go into the while loop, I'll just display like starting on floor 1, just to give the user a message so they know where they are. So once you implement all of the states here, I should have a working state machine, right? So I should be able to go up to floor 2, up to floor 3. If I try to go up, I can't go up. I can go down to floor 2. I can go down to floor 1. I can go down to the basement, right? So you see from the messages that I was able to travel floor 1, floor 2, floor 3, and then floor 3, floor 2, floor 1, basement. So I can go up and down. And when I'm done, I can quit. And there you go. That is what you need. So I have this text here that if I read my document here, it says after you have the code complete, which I just completed it, I should run my code and then copy paste from the command prompt showing that you can make the elevator go from the basement to floor 3 and back down to the basement. Include this in your report because it's worth 10 points. So yeah, so basically you're just finishing this code, which is what we just typed up. I put question marks in places. Obviously you need to remove those question marks. Also, remember, again, I'll say it again, if you're using MATLAB and not Octave, you're going to have to change these end ifs to just end. Okay, so you implement that and then you're done. Okay, so that's essentially it. So if I copy this and then I go paste it into a new file, I'm going to save this as something else. File, save as. Let's just call it like state machine 2 or something. I don't know. So here's my second state machine, right? So if you're going to change this to be for another state machine, you need to get rid of all of this code here, right? What do you need to keep? Well, whatever states you have, you need to set your current state and next state. That should stay. If you need to get input from the user, which you probably do, then you want to keep this input. If you're displaying something on the screen, obviously that should be relevant to your thing. Like you can change it to like starting at state 0 or something, or starting at S0, whatever it is, right? Maybe then you'd have to change that to 0 and 0 there, probably. Okay, so maybe it looks like this for a generic state machine. The while loop stays the same. This getting input from the user stays basically the same, but you need to change the message that's for that you're going to output. Like maybe you only want the user to type 0 or 1, right? Then in which case maybe your message looks like this. Input 0 or 1 or quit, right? You could do something like that. If the user types in quit, then you leave. That can stay the same. But these lines here, this is where you check the user's input. So the user valid input would be 0 or 1 then, right? And like, let's say the user can type in a 2, right? Maybe the user can type in a 2. So user 0, 1, or 2. I don't know why they would, but if you want that, you can do it. But just be careful because this if statement here only checks for 0 and 1. So you would have to add another condition here, another or string compare, right? Like if you wanted to check that. So you have the if the user typed in 0 or the user typed in 1 or the user typed in 2, right? So I changed that to get 0, 1, or 2. Now, why would you do that? I don't know. I'm just making up something up here, right? So obviously you can adjust this get input loop to match whatever your state machine is. Okay. Once you get input from the user, then you need to implement these blocks, right? Just like you did for the previous state machine. So they're always going to be like this. If the current state is 0, then, well, what's the input? What do you do if the input is up? Or, you would just change that to 0, right? And you have to fill these in, right? What happens if the current state is 0 and the user typed in 0? I don't know, right? You got to figure that out. Um, what do you do if the user typed in a 1 for the input? Well, I don't know. That's up to you. The main things you have to remember is that in this block of code, after you check the input, you need to set the next state to equal whatever the next state needs to be based on the current state of 0 and the user input 0. That needs to be set. And then if there's any output, this is where you display it. Just type it on the screen. That's all we can do. Okay. Output is whatever, right? Um, so it'd be pretty straightforward to implement most state machines. Like if you're doing those, a lot of the book state machines, um, a lot of the book state machines, if we go down to, let's see, 13.2 or whatever, like for a state machine like this one right here, right? This would not be that hard to implement. And this is an example of one that you could implement if you wanted. What would you have to change? Well, your states are 0 through 4. Okay, we're still starting at 0. So all of this can stay the same. Just we have 4 now. Starting it as 0, that can be the same. Get the user input. Well, here the only possible inputs are 0 and 1. So there would be no 2. So in my string here, that one that I added shouldn't be there. We should only get zeros and ones, right? And then if you're implementing this, you get down to your current state here, and you say, okay, well, when the current state is 0, what happens? Well, that's this line. So when the current state is 0 and the input is also 0, then the next state is going to be S1. So the next state should be 1. And the output would be here is 1. So we can just display that on the screen, output 1. Now the other option was input could be 0. So if the input is, or sorry, if the input could be 1. So if the input is 1, what happens? Well, you go to this state, state 3. So you say next state equals 3 and display the output. Output is, what's the output? Here, it'll be 0, 0, right? And there you go. So I've implemented this first line, right? Then you have to implement the second line. Well, easy. You just copy this, paste it, comment, change the comment to a 1 here. And what happens? Well, if the input is 0, you go to S1. Okay, that's actually already there. And the output should be 1, which it is. So that's already correct. This is correct. If the input is 1, then the next state is here, should be 2. So you change the next state to 2. And the output should be here, which is 1. So you say 1. And there you go. Now you've implemented this row, right? So it's not hard to implement these, right? It's just one if statement like this implements one row in your table. You just have to handle the next state, which is the f function, and the output, which is the g function, based on the input of 0 and 1. Right, so this is pretty straightforward. I hope that helps you complete the programming homework. And then just keep in mind that, let me go find it. Just keep in mind that if you have like something more interesting that you want to do, feel free. So here's a couple of suggestions, right? Like a vending machine, like you can get from the book or in lecture, or a traffic light. Problem with something like a traffic light is you might have to have a timer, which is going to be a little bit tricky to complete. You'll have to have a variable for the timer and you'll have to update it, and that'll be more tricky. But anyway, you write your own state machine here, and just make sure you show sample output of running it, right? Like this one that I just made. We've only implemented two states here, right? But if I run it, what's it called? What's it called? Finite state machine. It's called state machine two. State machine two, right? We only implemented. Um, oh, that's weird. Output is one. Output is one. Why output is one? Output is one. I don't know what happened. Um, I don't know why that printed twice, but you might want to print the current state as well. Was something I was thinking of. So like, you might want to do this. You don't have to, but something like that might help you. Output is one. Output is one. One. But okay, I still don't know what's going on. I feel like it's not reading the current code. Um, but I don't know. I'm not going to fix this. Oh, next state is one. Output is one. Output is one. Yeah, I don't know. Oh, I know. Okay, now I know. I said state one, and I didn't actually update um, that to be one. Okay, so that makes sense. So you might want to add lines like this in here just to tell you what the next state is as well as the output. But it doesn't really matter. Anyway, so that's about all I wanted to do there was just explain how to set up your state machine so you can show it running and make it work right. And notice that we didn't change anything in the structure to implement another kind of state machine, right? We just had to change a few details. The code for this state machine and the code for the elevator were nearly identical. So I hope that helps. Turn this in by the end of next week. And yeah, that's about it. It says May 19th, which is Thursday, but you can turn it in on Friday as well. So just try to get it in when you can. All right, that's it. Thanks for watching. Good luck on your programming.